Good evening, all of you. And here is the blend of probability and calculus. So let's start with the first question. Suppose we have all twice continuously differentiable function f such that f belongs to real to 0 to infinity, satisfying f double dash x into f of x is greater than equal to 2 times of f dash x whole square, where f of x is defined to be a collection of all polynomial of the form ax4 plus bx cube plus cx square plus dx plus e, where a, b, c, d comes from the set 0, 1, 2, 3. Right? So the question is, what is the probability that the function chosen will satisfy the condition on S? And what is S? S is set of all polynomial f of x such that it satisfies this guardians. Okay, so let's see how to solve this problem. It is a challenging one, but it's interesting. Okay, now you can decode this function f double dash f of x into 2f dash x whole square. Okay, resembles us of something, and if we'll think of, let's say, defining a function g of x as 1 by f of x, so it's fine to be defined because anyway the output of the function is 0 to infinity. We can differentiate and get g dash x equals f dash x by chain rule by minus of f of x whole square. So it's double derivative g double dash x is giving me differentiate upar wala, which is minus of f double dash x, leave denominator, it's whole square, minus leave upar wala, so f dash x into differentiate denominator. Right, so if I'll differentiate denominator, it's 2 times f of x into f dash x, so that will become f dash x whole square divided by f of x whole 4. So from here you can see clearly we can cancel f of x, so this will become whole cube, and we are left with 2 times of f dash square minus f double dash times f over f cube. So far so good, it's just g double dash x. So now we know already, according to the given condition on set S, this is greater than equal to 0, so this quantity is greater than less than equal to 0, right? So from the given set we know this is less than equal to 0, which shows like g is a concave function, its nature is concave. Concave means how it will look like, since derivative is less than 0, double derivative, so now the rate of change of slope is negative. Okay, so rate of change of slope is negative, so something like this, concave down. So you can say at this point slope is 0 and slope is some negative value, further it's getting negatives. So from positive the slope is going from positive to 0 to negative. So roughly the graph will be like this, right? Now we'll show that the function g will be constant. See how? Because if I'll take arbitrary real number, say a and b, any two real number a and b, and without loss of generality, let's say a is greater than b. So by concavity of g, we can tell, like for all u less than a, okay, and b which is more than b, what you can tell, like ga minus gu divided by a minus u will be greater than gb minus ga divided by b minus a, and that will be greater than gv minus gb divided by v minus b. So combining this with gu and gv greater than 0, because you know gu and gv is greater than 0, because anyway we are defining function output to be positive. So what we'll get? We are getting ga by a minus u is greater than GB minus GA divided by B minus A, because anyway this quantity is positive. Okay, so if it is positive, so this will be lesser than GA by A minus. Similarly, this is GB is also positive, so I can tell if you are taking away positive minus something, that will be definitely greater than minus GB. Let me not put the strict equality case, divided by B minus B. तो यहाँ से what we got, GA by A minus U, from this step is GB minus GA by B minus A, and that's greater than minus GB by B minus B. Now you can take, you can clearly see if I'll take the limit U tends to minus infinity and B tends to infinity. So what we are getting, if B is tending to infinity, you know for this quantity is going to be what, 0, and this is also going to 0. Okay, so now when we take limit, equality will come, of course, because from sandwich theorem you know, because if these two quantity is sandwiched between 0 and 0, so the only possibilities is this GB minus GA by B minus A should be 0 identically. It means if I take any pair of A and B, any pair if I pick up A and B, so in that interval GA and GB is equal, okay, for any 2 points. Now clearly I can slide this point. Suppose instead of this 2 point I would have taken this 2, and still these values are equal. If I would have taken this to this value is equal. If I would have taken this to this 2 value is equal. It means in the entire domain it's kind of chain reaction, where entire domain every value is equal. So what we got? So since this holds for any pair of NB, so g of x is constant. So if g of x is constant, so that gives me 1 by f of x is constant. 1 by f of x constant, it means f x must be a constant function. So there is no way out. Okay. So now what is the chance? Like the randomly function selected will satisfy the condition on this. So how many function you can select? How many such expression can be selected? This is polynomial function. So a, b, c, d can take a value of, a can take 4 values, right? 1, 2, 3 or 0. So a will have 4 choice. Similarly, b will have 4 choice. 4 into 4, c is have 4 choice. D is having 4 choice and E is having 4 choice. The total number of functions that we are having is 4 to the power 5. Out of this, how many functions will give my required condition? So all those functions which are constant. Okay. So now for constant function, all these value a, b, c, d, a equals b equal to c equals d must be 0, and E can take any value from the set 0, 1, 2, 3. So the answer is 4 by 4 to the power 5, which is 1 by 4 to the power 4 is the probability. I hope you must have understood and enjoyed the problem and see how calculus can be related with probability, right? Of course, here while doing this, what I have assumed, as I have told, we have A and B and this length. Okay, so I have taken 2 arbitrary number and I have taken a case when U is less than E. Okay, so U is some point here and B is more than B and B here, and then I have applied, you know, concavity is here, here and in this interval. I hope it's quite clear. Okay, so I have applied concavity for this interval, this interval, this interval, and then I have shown by a very fundamental theorem, like if I apply concavity here, it will be constant for the entire interval. Of course, you could have thought the problem in the second way also, because the idea is how to bring up, you know, like f double dash times f greater than or equal to 2f dash square into picture. So it's also not very difficult, and as a rough work, I have always asked you to put equality for this kind of problems. So roughly if you'll see f double dash by f dash square, or f dash, I can write 2f dash by f. So if we'll take integral on both sides, so rough feeling gives it's going to be log f dash equals to ln f. Okay, so f dash is kind of f square, and again f dash by f square dx gives you, you know, like if I take 1 by f as some u, it's kind of minus 1 by f square, df is du. So in that sense, we are getting minus 1 by f kind of feeling. Okay, so that was my temptation of bringing 1 by f into picture, 1 by f or minus 1 by f. I hope the motivation was clear. But still there is another way of, tackling this problem. Instead of the function 1 by f of x, we could have used the function tan inverse, f of x. The reason being, this is also potential of giving f dash and 1 by something s square. So let's take, if I take this as psi, so what is psi dash? So it's 1 by 1 plus f square into f dash x. And now if we'll differentiate it again, psi double dash with UV rule, you can say it's clearly f double dash minus 2f dash square by 1 plus f square. So this quantity is getting 0. Okay. And now we know, since tan inverse f of x, and f of x is what? F of x output is belongs to 0 to infinity, as we have seen in the problem statement. You see, all the polynomial function f of f will not belong to this interval. Okay. So actually the set S was this entire included. So this was the condition for set. Because if you will not take this condition of f incorporated in the set, then definitely you will tell the sample size will not be 4 to the power 5, right? So your logic will be correct in that case. But I want S is the set of f such that this holds and f is going from R to 0 to infinity, satisfying this. तो ये एक बहुत ही खूबसूरत सा प्रॉब्लम था. अब यहाँ पे देखो, यहाँ से डायरेक्टली यू कैन कंक्लूड विदाउट एनी लाइक थिंकिंग ऑफ concavity, because tan inverse f of x, tan inverse x graph will be some monotonically increasing function and bounded also between minus pi by 2 to pi by 2. This is graph of tan inverse x. Now we know tan inverse something is it's going from where to where. F of x is 0 to infinity, so still it's increasing, right? And it's a bounded function. And what kind of curve we are getting? So since tan inverse f of x is a bounded convex function now, convex function. So from here we are getting what will be the behavior of psi. Psi's double derivative is positive. It means psi will be concave. Okay, because slope is increasing, psi double dash is positive. So it is showing that psi is concave up. And if psi is concave up, means tan inverse f of x is concave up. But it's already convex down. But it is showing like it's convex up. So it's not possible. It's possible if and only if the function becomes constant function. Okay. Otherwise, if it varies, so this condition can never be achieved. इसका मतलब f of x को constant होना ही पड़ेगा. तो ये बहुत बेहतरीन सा प्रॉब्लम था, जहाँ पे आप देख सकते हो कैसे आप बेसिक आइडिया से इसको हैंडल कर सकते हो. Let's take the second example. Let's take the second example to understand this. Suppose we have a function defined from set A to B. Okay, such that set A is given by 1, 2, 3, 4, 5. It has got 5 elements, and set B is, let's say, 1, 2, 3 elements. You can do for different, like proportion of set also, different number of elements. I'm doing for one standard problem. So first question is, what is the probability that a randomly selected function is onto. Second is probability at randomly selected function is let's say bijective. And third is probability that randomly selected function is non-decreasing. Okay, so let's solve all this problem first. The first one is what is the total number of sample space, ns, number of elements in sample space. That is basically set A has 1, 2, 3, 4, 5. Set B has 1, 2, 3. यहाँ से clearly you can see 1 is having 3 options, 2 is having 3 options, 3 having 3, 4 having 3, and 5 is having 3. So we have total ns is 3 to the power 5. Okay, now these elements and functions are selected randomly. So we want in the first case how many are onto. Achha, onto means each and every element in the output set B must be exhausted, means must be linked with something. For example, one example of onto function will be 1, 2 going to 1, 3 going to 2, 4 going to 2, and 5 going to 3. So method 1 of doing onto function is very easy. You can imagine as if we have 3 boxes, b1, b2, b3, and that represents fundamentally this set, okay, set B, and we have balls like b1, b2, b3, b4, b5, 5 distinct balls and 3 distinct balls. Now it's basically same as asking the question in how many ways you can put these 5 distinct balls into 3 distinct boxes so that none of them is empty. The only possibilities of number of balls in boxes will be either 2 1 1, sorry 2 2 1, 2 2 1, or it will be 3 1 1. Now in how many ways you can put 2 1 2 2 1 balls? So first let's make a group of this. Out of 4 I can select any 2 balls. Okay, let's say b1 b2, then remaining I'll select again, remaining 2 I'll select. So let's make case out of 5 I'll select any 2, then from the remaining 3 I'll select any 2, and the remaining one will automatically be selected. Okay, but while doing so, what I'm doing is we are making same group also, because there will be case when b1 b2 and b3 b4 will be selected. There will be case when b3 b4 and b1 b2 is selected. So to account for that I am dividing by 2 factorial. Now these are the number of groups that I am having. Now this group will be distributed to 3 boxes, so that will be multiplied with 3 factorial, because once you have made these 3 packet I have to give to 3 boxes. Let's say Ramsam Ghansam box, so into 3 factorial. So ये calculation कितना रहा है 5 factorial by 2 factorial into 3 factorial into 3 factorial by 2 factorial into 1 anyway into 3 factorial divided by 2 factorial, right? So यहाँ से 3 factorial gets cancelled, 2 factorial will give 3, so we have 2 factorial, so 3 4 5 and 2, so 30 30 90. Similarly, let's see the other case. So from here we are getting 90. So let's see the second case. So you can clearly see now we will select 5C3, 5 में से 3 ball, remaining 2 ball में से 1 and remaining 1 में से 1. Now again it might happen like you are selecting B1, B2, B3 and let's say B4, B5. Right, in this 5C3, B1, 2C1, B. Or maybe in 5C3 again I have selected B1, B3, B3, but this time in 2C1 I selected B5 and then B1 and then B4. So you see again it's same counting. Okay, so since group size is still same, so still I need to divide this by 2 factorial because 2 group size can interchange. The number of packets कितना बना 5C3 which is 10 into 2 divided by 2 factorial which is 10. Now once I have 10 different group size, 10 different group size मतलब एक group having 1 2 3 then 4 5. Okay, now we'll have no group like 1 2 3 5 4. Okay, this is not counted in 10. Now other group will have different genetics 1 2 4 and then 3 and 5. फिर ऐसा कुछ होगा जैसे 2 4 5 1 3 करके, तो ऐसा ऐसा 10 ग्रुप बनेगा. Now once you have any group, let's say if I have got this group, okay, now this group can be given to this 3 box in how many ways? In 3 factorial ways, क्योंकि इस ABC can go to this B1 B2 B3 in 3 factorial. या तो इसको A जाएगा, B जाएगा, C जाएगा, या फिर B जाएगा, A जाएगा, C ऐसे 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 3 factorial. That's why we need to multiply with this 3 factorial, which gives 60. Total answer क्या आ गया 90 plus 60 which is 150. So the probability for first option, first problem is 150 by 3 का power sample space 5. Okay, next question was the probability that it's bijective. वही बोल रहे हैं ना, अब बाइजेक्टिव तो होगा ही नहीं क्योंकि देखो क्योंकि ये वो 1 1 तो हो ही नहीं पाएगा. If it is on to at least, okay, if it is on to it cannot be 1 1 because 4 and 5 must go to some element which is already mapped. So second probability is 0. Third is probability is non-decreasing. Now what is the meaning of non-decreasing? Non-decreasing means either for if x is more than y, okay, if x is more than y, then the function value of x will be either more than function value of y or it will be equal to. इस टाइप के फंक्शन को हम नॉन डिक्रीजिंग करते हैं. Means it should not decrease, either it will be constant or increasing. For example, suppose if you have a function like this, okay, so this is a non-decreasing function. क्यों? क्योंकि या तो ये इंक्रीज कर रहा है नहीं तो कांस्टेंट हो रहा है, डिक्रीज नहीं करना चाहिए. तो अब देखो, अब दैट इज इंटरेस्टिंग. लेट्स से इफ यू हैव 1 2 3 4 5 एलिमेंट्स इन सेट ए, सो थर्ड पार्ट एंड 1 2 3 एलिमेंट इन सेट बी. ठीक है. अब नॉन डिक्रीजिंग के लिए जैसे एक एग्जांपल देखते हैं. सपोज 1 1 को गया, 2 1 को गया, 3 2 को, 4 2 को, 5 3 को इज द करेक्ट आंसर, राइट. लेट्स टेक अनदर सिचुएशन just to get a feel of the situation first. 1 1 को, 2 2 को, 3 3 को, 4 5 3 को, like this. So like this you can draw many situations. I'm just drawing one more for our satisfaction. 1 2 3 4 5, 1 2 3. Let's say 1 goes to 1, 2 goes to 1, 3 goes to 1, 4 goes to 1 and 5 goes to 2. This is also correct. One more just for last feel. If everything goes to 2, it's also correct. Is this correct? Is this possible that everything goes to 2? Yeah, it's possible, right? Because number of non-decreasing function is whenever input is more than output, when x is more than y, the output should be either equal or more than this. So how to solve this problem? One of the very beautiful method of doing this is, if you'll see all these 4 solutions, okay, and think from set B perspective. I'll give you logic like why I am thinking from set B perspective. So 1 is having how many connection? 1 is having 2 connection. You see 2 of them. 2 is having 2 connection here. 3 is having 1 connection. So clearly how many connection it will have, since it's of course non-decreasing on 2. तो इसके पास कितना connection है? 5 connection. In the second situation, 1 is having 1 connection, 2 is having 1 connection and 3 is connected to 3 of them. Here 1 is having 5 connection, 2 is having 0 connection, 3 is having 0 connection. यहाँ पे 1 इज हैविंग 0 कनेक्शन, इसका 5 कनेक्शन, इसका 0 कनेक्शन. आप देख रहे हो क्या है. सो इन एनी ऑफ द सैम्पल सिचुएशन, वॉट एवर यू डू, वन थिंग इज गारंटेड. एनी सैम्पल सिचुएशन, 1 will have let's say x connection, 2 is having y number of connection, and if 3 is having z number of connection, I am sure x plus y plus z is equal to 5 because of conservation of mass. ठीक है. Because of the definition of function ऐसा तो होना ही होगा. बट एक्स वाई जेड कैन बी ग्रेटर देन इक्वल टू 0, क्योंकि 0 0 भी पॉसिबल है. देखो जैसे यहाँ पे 5 0 0 पॉसिबल है. सो फंडामेंटली इज आस्किंग द क्वेश्चन हाउ मेनी नॉन नेगेटिव इंटीग्रल सॉल्यूशन दिस इक्वेशन हैज. ओके, तब इसका कितना इंटीजर सॉल्यूशन होगा. सो यू कैन थिंक इन दिस वे. 5 आई कैन राइट 1 2 3 4 5. ओके, नाउ आई हैव टू डिवाइड दिस 5 into 3 parts so that sum of them becomes 5. So 3 part I can feel like, let's take a divider, 1 divider and 2 divider. Now 2 divider will automatically divide into 3 part. So देखो one solution is 1 1, other is 3. So whatever is left to first divider, divider number 1, divider number 2, and so solution is given like this. You think of a number which is left to divider 1, right to divider 2, and other what is trapped between divider 1 and 2. तो यहाँ पे is correspond to 1 1 and 3. यहाँ पे एक बचा और 3 बचा. Now suppose if someone will take divider over here, suppose यहाँ और यहाँ, so he will get then 3 1 1. Now what if someone takes divider just to the leftmost point, okay, and second divider also over here, let's say both here. So we have 0 trap and all 5 trap. So this gives solution 0 0 5. I hope you are getting the feeling. अब जैसे 5 0 भी आप ला सकते हो. डिवाइडर यहाँ हो गया, फिर यहाँ आ गया, तो all 5 is there and nothing. Okay, so now my claim is like corresponding to any solution here, there is a unique mapping which is non-decreasing. For example, suppose if you have 5 0 0. अब 5 0 0 मतलब हम क्या डिफाइन कर रहे हैं. जो 1 के पास 5 कनेक्शन है, 1 2 3 4 5. 1 के पास 5 कनेक्शन है एंड 2 के पास कुछ नहीं, 3 के पास. So देखो like this is definitely a non-decreasing function, right? Now some of you will tell, sir, but how you are telling is non-decreasing. Suppose 5 0 0 also 3 4 5. 5 0 0 can give answer in another way. जैसे 2 is having 5 connection. नहीं, that's different thing because now 1 is having 0 connection and 5 0. So that's already 0 5 0 is another solution counted by our this counting method. ये तो समझ में आया ना. तो एक तो ये यूनिकनेस बन गया. फॉर एग्जाम्पल 1 2 3 4 5. सपोज यू आर गेटिंग 3 1 and 1. तो इफ 1 इज हैविंग 3 कनेक्शन, तो 1 के पास 3 कनेक्शन क्या होगा, 1 2 3, एंड 2 वाला के कनेक्शन 1 कनेक्शन 4 and 3 वाला का 5. नाउ हियर डाउट कम्स बिकॉज लेट्स से समवन टेल्स लाइक, सर आई हैव अ डाउट, एंड डाउट इज when you tell 1 is having 3 connection, why not you can connect 1 with maybe 2, 3 and 4, and 2 is having 1 connection and 3 is having 1 connection. So this is also counted in your solution. So when my solution has given 3, 1, 1, it can give birth to this picture or many picture actually. But you see, out of all these pictures there will be only one unique picture which will be non-decreasing. क्यों? क्योंकि अगर 1 को कनेक्ट करना है and you know the next output must be connected with the more input, it means 1 has to pick up the first 3, then 2 has to pick up the next, and 3 has to pick up the next. It means all these options with 3, 1, 1 will go. So out of all the possible situations of 3, 1, 1, only one situation is the desired situation, so it automatically counts. आई होप इट मेक सेंस. ठीक है, हम क्या बोल रहे हैं, आप 3, 1, 1 को तो बहुत ज़्यादा रिवर्स में तुम मैप कर सकते हो, लेकिन जो कंडीशन हमें चाहिए वो तो सिर्फ एक ही यूनिक कंडीशन है ना 3, 1, 1 के करस्पॉन्डिंग. तो तुम कोई भी सॉल्यूशन सोचो, जैसे 5, 0, 0, इसके करस्पॉन्डिंग एक यूनिक ही आंसर है जो मुझे चाहिए. तो इट मीन्स नाउ द क्वेश्चन जस्ट बॉइल्स डाउन टू नंबर ऑफ फाइंडिंग नॉन नेगेटिव सॉल्यूशन. तो अब वो क्या हो गया, वो बेसिकली इट्स अ गेम ऑफ यू हैव 1, 2, 3, 4, 5 आई वाज एक्सप्लेनिंग, एंड यू हैव 2 मार्कर्स. अब 2 मार्कर और ये 5 वंस को तुम कितना वे में सजा सकते हो, तुम जितना तरीके से सजाओ उतना सॉल्यूशन देगा, क्योंकि 1, 2, 3, 4, 5. अगर मान लो हम दोनों मार्कर को यहाँ पे रख दें, देखो ये सजाना ही हुआ ना, तो मेरे पास कितना सॉल्यूशन आ गया, 1, 2 एंड 2. ये सॉल्यूशन कितना दिया, 0, 1 एंड वी हैव 4. तो अब कितना वे में सजा सकते हैं. सो जस्ट लाइक टेलिंग, लेट्स से मार्कर इज मार्कर 1 and marker 2 markers because they are identical. It doesn't matter whether m1 m2 is there or m2 m1 is there, क्योंकि वो सॉल्यूशन तो एक ही जगह 0, 1, 4. और मेरे पास कितना फिर वंस है, तो लेट्स से 1, 2, 3, 4, 5. अब इसको कितना में अरेंज कर सकते हैं, इट्स जस्ट अ बेसिक अरेंजमेंट प्रॉब्लम. टोटल 1, 2, 3, 4, 5, 2, 7 फैक्टोरियल डिवाइडेड बाई a string of 2 same group size 2 factorial divided by 1 is same 5 factorial. So it's nothing but 7c 5 or 7c 2. So the answer for this problem is 7c2 divided by 3 to the power 5. So I hope you have enjoyed the lecture and understood how basic counting problems, with functions or calculus with functions can be.